Serpieri. Serpierite is a rare, sky-blue colored hydrated sulfate mineral, often found as a porous mining product. It is a member of the devilline group, which has members aldridgeite, campigliaite, devilline, kobyashevite, lautenthalite, and an unnamed dimorph of devilline. It is the calcium analogue of aldridgeite, and it is dimorphous with orthoserpierite. It was discovered in 1881 and named by Alfred Des Cloizeaux in honor of. Serpieri was an Italian revolutionary engineer and mining entrepreneur who developed mines in the Lavrion area of Greece and founded the Montecatini Company. He was born in Italy in 1832 and died in Greece in 1897. Crystallography. Serpierite is a hydrated sulfate with a formula with molar mass 644.32 g and calculated density 3.8 g/cm3. It belongs to the monoclinic crystal system, point group 2/M and space group C4/C. It is pseudo-orthorhombic and structural with aldridgeite. The units are a side of Let 22.2 A ring, side C of Let 21.9 A ring, and the angle beta between them equal to 113.4 degrees. The third side B, which is perpendicular to both A and C, has length 6.25 A ring. There are 8 formula units C equal 8 per unit cell. Appearance. Serpierite is a sky blue colored mineral with a white or almost white streak and a vitreous luster, pearly on cleavages. It is transparent and appears greenish blue in transmitted light. No large crystals have been found. It occurs as tufts and crusted aggregates of lath-like or bladed crystals, typically less than 1 mm longitude. These crystals are elongated along the crystallographic direction and flattened perpendicular to the C direction. Physical properties. Sources differ widely about the hardness of serpierite, giving values varying between 2 and 4. They all agree, however, that the specific gravity is 3.7, a very little less than the calculated value. Cleavage is perfect perpendicular to the C direction, which is the direction in which the crystals are flattened. The mineral is brittle and breaks with a splintery fracture. It is soluble in acids and it is not radioactive. Optical properties. Monoclinic crystals, entroclinic, and orthorhombic crystals have 2 directions in which light travels with 0 birefringence. These directions are called the optic axes, and the crystal is said to be biaxial. The speed of a ray of light traveling through the crystal differs with direction. The direction of the fastest ray is called the x direction, and the direction of the slowest ray is called the z direction. X and z are perpendicular to each other, and a third direction, y, is defined as perpendicular to both x and z. Light traveling along y has an intermediate speed. Refractive index is inversely proportional to speed, so the refractive indices for the x, y, and z directions increase from x to z. For serpierite, the orientation with respect to the crystal axes b and c is y equal b, c equal c, and x is inclined to an angle 24 degrees. The refractive indices are n alpha equal 1.58, n beta equal 1.64, n gamma equal 1.65. The maximum birefringence delta is the difference between the highest and lowest refractive index. For serpierite, delta equals 0.65. The angle between the 2 optic axes is called the optic angle, 2v, and it is always acute and bisected either by x or by z. If z is the bisector, then the crystal is said to be positive, and if x is the bisector, it is said to be negative. Serpierite is biaxial, and the measured value of 2v is 33 degrees to 37 degrees. Also, 2v can be calculated from the values of the refractive indices, giving values close to the measured values. Different sources give 34 degrees, 37 degrees, and 37 degrees +/6 degrees. 2v depends on the refractive indices, but refractive index varies with wavelength and hence with color. So 2v also depends on the color and is different for red and for violet light. This effect is called dispersion of the optic axis, or just dispersion, not to be confused with chromatic dispersion. If 2v is greater for red light than for violet light, the dispersion is designated RV, and vice versa. For serpierite, dispersion is strong, RV. The mineral is plechoic. When viewed along the x direction, it appears pale green and bluish green along the y and z directions. Occurrence. The type locality is the Serpieri mine, Camorese, Lavrion district, Greece, and type material is conserved at the National Museum of Natural History, Paris, France. Reference 73.38, 78.226. Serpierite is a secondary mineral found in altered smelter slags and oxidized sulfide veins. At the type locality, it is associated with smithsonite, and it has also been found associated with devilline, positokite, catenosite, linorite, langite, brochantite, rowolvite, namuite, schillenbachite, hydrazensite, malachite, and gypsum. Localities. Scatterings of sky blue serpierite needles have been collected in dump material from the Kent and Block 14 open cuts, Broken Hill, New South Wales, Australia's matted crusts and hemispherical sprays to 0.5 mm with a silky luster. The most commonly associated sulfate minerals are schulenbergite and brochentite, with less abundant antlerite, keratensite and linorite. The serpierite contains appreciable zinc. At the Lloyd Copper Mine at Broga, New South Wales, serpierite and langite together with other species coat the bed of an open adit that drains water affected by acid mine drainage from the open workings. At the Tiny Bottom Mine, Garrigal, Cumbria, England, porous mining deposits have been found containing serpierite as pale turquoise blue radiating, usually flat, crusts of feathery needles with a silky luster. Individual crystals are up to 0.5 mm longitude at the Brownlee Hill Mine, Alston Cumbria, England. Serpierite occurs with hormatome and gypsum, and rarely with brochentite in fractures in quartz lining of a large cavity in a Brownlee Hill vein. The aggregates of blue lath-like crystals reach about 2 mm and appear to have been produced by porous mining oxidation of chalcopyrite. Serpierite is extremely rare at Red Gill, Coldback Fells, Cumbria, England, where it has been reported as soft, pale blue micaceous aggregates on xerisite. It is probably a dump-formed mineral. Acicular serpierite crystals to 1 mm have been found in Neudorf in the Harz Mountains of Germany as leafy pale blue iridescent crystals overgrown by gypsum and argonite. At the old copper mine of Ross Island, Killarney, County Kerry, Ireland, specimens of serpierite were obtained from dump debris from a large waterlogged hole called the Blue Hole. The ores worked in the Blue Hole were sphalerite, galena, pyrite and chalcopyrite. Smithsonite is tolerably abundant.